Welcome to the project demonstration of AC and DC EV charger. Here we are getting AC output and DC output for electrical vehicle charging. Some electrical vehicles need DC power supply and some electrical vehicles need AC power input. So that we have developing directly one input that is 230 volts AC input to this charger EV charger setup, and it will provide us the two outputs. One is AC 230 volts, AC outputs, and there is a DC outputs. The AC variable voltage output getting from this variable rotary, and when we are rotating this, the variable output voltage of AC is from 24 volts to maximum of 80 volts AC we are getting that. So variable output from here. And coming to the DC, it's a fixed output, as we know that most of the electrical vehicles consist of 48 volts DC power supply needed batteries, and then we need to provide around minimum of 52 volts, maximum of 55 volts to charge those batteries. So for that purpose, we are making use of electrical circuits backside of this panel board. So this is our main panel board. So from this cable, we are going to provide the 230 volts AC inputs to this variable transformer, so which will provide us a variable AC power supply, and that was given as output from here to this box. And next, so this will take 230 volts AC inputs and will provide us the 20 amps of power here, 20 amps of current, so that we are getting around 960 watts of power. Nearly 1000 watts power can be achieved from this charging circuit for the electrical vehicle charging. So coming to the DC power circuitry, so we can connect this directly to our e-bikes, so that from here we can charge our e-bike battery setup. And the next, so the generated or the converted voltage will be monitored by continuously with help of Arduino Uno. So there we are going to use voltage sensors, two different types of voltage sensors. So one is a DC voltage sensor and there is a AC voltage sensor. So the DC voltage sensor consists of 10 kilo ohm and 1 kilo ohm, as we are dividing the voltage using this potential divider circuit. So from there we are going to measure the voltage across the 1 kilo ohm, and as you know that V in is equal to V out into total resistance by across resistance, nothing but we are considering here R1 is 10 kilo ohm and R2 is 1 kilo ohm. So the main, what is the input voltage equal to? The V in is equal to V out. So how much of we are getting from the 10 kilo ohm resistance, and total resistance is 11k by 1 kilo ohm. So that is a formula for measuring the input voltage from this potential divider circuitry. And coming to the AC potential divider circuits, so as you know that controller can't measure the AC voltage. For that purpose, we are going to use DB107 rectifier AC. Before that also we are using same 10 kilo ohm, but here 3.3k. So nothing but we are going to dividing the voltage in 1:3 ratio, and there across the 3.3 kilo ohm resistance will be given to the DB107, which will convert the AC to pulsating DC, and after this capacitor we will get the pure DC voltage. And after this also we are going to using one more same potential divider circuit, that is 10 kilo ohm is 1 kilo ohm, so 10:1. So that particular voltage continuously monitored from the A0 pin for DC power supply and A1 pin for the from the AC voltage sensor. So that will measure by this analog pins of this Uno board. And the next, so LCD will show the data. So the LCD connected at pin number B2 to B7. So let us see the demonstration. So just by switching on this, so there will be a welcome message on the LCD screen. So initially this is the restart switch, just to restart the microcontroller. Initially actually this is the off and total timer off. So now the total system in off state. So whenever you want to on the charging circuit for the DC power supply or AC, just on this and on the timer. So there are two LED indications. One is a power LED indication, means it will show the status of the charger got switched on and it's working and charging, nothing but. So when it turned into the green lights, then automatically it will indicate it as the battery got fully charged and the power supply will be isolated from the charging circuits. So there we can see the DC. The above line is a DC voltage and next DC power in watts, and below is the AC voltage and the timer. So we have started it, 30 seconds is completed now. So let us check by varying the AC input voltage. Right, its maximum reached up to 100.5 volts, 100 volts, so around that. Right.